Okay. So we're going to start 4-7 today. And you can actually just chop 28 through 31. You don't have to. I changed my mind. So, 28 through 31, you can chop off your homework. You don't have to do it. Okay? All right, 4-7. So today we're going to talk about, or start talking about, okay? Now instead of doing rational equations, we're now going to do radical equations. So instead of having a fraction in every problem, we're now going to have a radical in every problem. Yay. Okay. All right. So first thing we need to talk about here is the concept that came up in our homework when we were going over some stuff yesterday, and that is extraneous solutions. Extraneous solutions. Okay? And what did we say sometime? What's another way of saying that? Fake answers. Okay? So really, what is an extraneous solution? It appears to be a solution algebraically, but if plugged back in, or tested, it's a false solution. So basically, again, it's when you get an answer, you expect it to work, then you go back and check it, and you find that that answer makes the domain not exist or something like that. Now, this happens a lot more frequently with radical solutions than it did with rational solutions. Because with radicals, like if I have a square root, what can I not have under a square root? A negative. So if you get an answer for x, and you plug it back in, and you see that it gives you a negative number under a radical, that's going to end up being a extraneous solution, because it's not a true solution. It doesn't work on both sides. Okay? Or it just gives you two equations that are not equivalent. Okay? So we're going to have to test every solution for these problems. So when we do this, we have to test what we get for x or y or whatever variable. So we have to check our solutions. Okay? All right, so we're going to look at an example here. We got x equals the square root of x plus 5.
So we're basically doing a problem that doesn't have an answer right now?
No, this one actually works.
Oh.
Good question.
All right, so we get that.
Whoa.
Is it 5 out there?
Yeah, 5 is outside the radical. So I got x equals the square root of x plus 7 plus 5. So the 5 is outside the radical. So, okay, I'm not sure if you like when I give you steps. I'm a person that works in terms of steps. I think it makes processes easier to learn. So I'm going to kind of give you the steps that I use when I'm solving these. So step 1 is you want to isolate the radical. So what do I mean by that? I want to get the radical by itself. So if there's anything added, subtracted, multiplied, or divided outside the radical, I want to move it to the other side. I want to get the radical by itself. Okay? Step 2. Get rid of the radical. So how do I get rid of a square root? You square it. But whatever you do to one side, you have to do to the other. if it was a cubed root, what would you do to both sides?
Cubic.
Cube it, take it to the third power. If it was a fifth root, you'd take both sides to the fifth power, etc. Okay? And then after that, you're going to solve for x. And then last step, check your solutions. So this is not as long of a process as some of the other stuff we've done, but I want to make sure we talk through it. So, looking at now, that's really no different than how you would solve anytime you have a radical. Okay? So, what's my first step here? What do I need to move or the 5, right? That 5 is not allowing me to have the radical by itself. So I move 5. I have x minus 5 equals square root of x plus 7. Okay? Did I isolate the radical? Is the radical by itself now? Okay? Get rid of the radical. So what do I need to do to both sides? Square it. Square that. I also have to square that. The key thing here, I have to square this, but is it just square both terms, or what do I have to do when I have a binomial square? Foil. Good. I have to foil this, because it's really x minus 5 times x minus 5. So if I foil this, I get x squared minus 5x minus 5x plus 25. Because remember, this is x minus 5 times x minus 5. Yep. You can combine like terms. And then on the right side, the square and the square root just cancel out. So all I have is x plus 7. And I'm going to pause because I know I'm going fast. Now, combine like terms. Left side I get x squared minus 10x plus 25 equals x plus 7. Now I need to move the x and the 7 to the left. Got to get everything to one side. So I get it equal to 0 and can solve it as a quadratic. So I subtract x, and I subtract 7. So if I do that, I get x squared minus 11x plus 18 equals 0. Yep. And now at this point, this is just a base quadratic, right? This one does work AC, so we can either AC, quadratic formula, or if you really want to complete square, you can complete square. So if I do AC, 1 times 18 is 18. Two numbers that multiply to 18 and add to negative 11. Negative 9, negative 2. Very good. So I get x squared minus 9x minus 2x plus 18 equals 0. Good. Now what? Split. First two have x in common, so I have x minus 9. Second two, negative 2, and I get x minus 9. So I get x minus 2 and x minus 9. So that tells me x equals positive 2 and positive 9. But now, what do I have to do to both solutions? Check them. Check them. So I get 2 equals 2 plus 7 plus 5. So I get 2 equals square root of 9 plus 5.
No.
2 equals 8. Is that true?
No.
Yeah. No. Wait, what? 2 does not equal 8.
Does 2 equal 8?
Oh, no.
Does it go plus or negative though?
No. Nope. So 2 does not equal 8. So what's that tell me about 2?
Fake.
It's fake. It's extraneous. Now if I try 9. 9, does that equal 9 plus 5, or plus 7 plus 5?
Yeah.
Does 9 equal the square root of 16 plus 5?
Yes.
Does 9 equal 4 plus 5? Yes, it does. 9 equals 9.
So 9 works.
9 works. So in this case, if I ask you for the solutions, you would say there is 1, and it's x equals 9. That's it. Now, 2 looks like it should work, but this is why it's really important you test. Because if we would have had that this was a negative 3 instead of positive 3, it would have worked. But again, it's not. Because you can't have negatives with square roots. Does that make sense?
Why doesn't it come out positive?
So it has to equal itself.
Plus or negative?
I like the square root.
Oh, here?
Yeah.
Because you didn't personally draw the square root. So like it's only when you're doing quadratic formula or something where you're taking it from a power and breaking it down. When you go in reverse, you don't put plus or minus. If I give you the radical, you never bring that back.
So if neither of them were equal, I would write no answer.
You would say no solution. Yep. So if neither answer work, you say no solution. And that is possible. Okay. So here's last one I want you to try, and we'll pick up here on Monday. So you've got a few minutes yet. You should be able to get this done. All right. So I've got 4 equals the third root of x plus 2 plus 8. Follow that same 4-step process. I'll give you about 2 minutes, 3 minutes, and then I'll quietly work through it up here, and you can look at your answer when you're done. So isolate the radical, get rid of the radical, solve for x, check.
Oh yeah, I didn't check it before. I'll check it out.
How do you put 3 in front of a square root sign?
On a calculator?
Yeah.
You push, so you push 3, and then second, and then the caret key. Negative 65.
Well, but you add 2 underneath, right? Okay, did everybody get x equals negative 66? All right, excellent. We will pick up there on Monday.